Hello, I am Titas. I am faculty of Globsyn Physics School. Today I am going to talk about neurons, which is the basic building block of artificial neural network that's a part of deep learning. Let's start. Biological brain always puzzles scientists. Take an example, a small pigeon's biological brain can do lot more complicated thing that today's computer with lots of electronic components with loads of storage spaces and running at much faster frequencies compared to those biological brain cannot do. Why it is happening? Why pigeon's brain is much more powerful than today's computer system? Let's see the basic architectural difference. Today's computer system supposed to do, they processes data much more sequentially, and they always processes data in a constant terms. There is no ambiguity, there is no fuzziness in their activity. But on the other hand, biological brain processes data parallelly, and fuzziness and ambiguity is main feature of the biological brain. So what is the secret? I have already revealed one of the secret, that is parallel processing and fuzziness. There exists another secret, another caveat. In order to understand that, we need to know how a biological neuron works. A biological neuron is taking electrical signal through its dendrite and passes that thing through actions and releases output. But we have a small caveat here. Not all input generates output. Only those inputs that are important enough, they generate output. In technical term, only those input whose summed up value crosses a threshold, then only a output will be generated. For not all input, output will be generated. This is the way the neuron work. This is the way we as a human brain feel world. We can smell, we can see, we can react to incident, we can touch, we can feel pressure. Everything happens because of this particular feature of neuron. What is that feature? Neuron does not generate output for every input value. Only the input value which are important enough for which output is generated. This particular fact is suggesting us to do calculation in a different way. So we mimic neurons, and we can do that. I am showing you one such example. Take this one. Here I am giving you a design of a artificial neuron. Like biological neuron, artificial neuron is taking input. And then what is happening here? The entire input is summed up. And then that summed up value is going to a threshold function. The threshold function's main job is to check whether that sum is crossing a particular threshold or not. And if it is crossing a particular threshold, then only output is generated. Although this is a very simple example, only to make you understand how neurons work, but basically this is the fundamental design of a neuron. As we have seen that in biological brains, neurons are actually layered. There are multiple neurons. There are n number of neurons, and they communicate with each other. Similarly, we follow the same thing in our own attempt to mimic the way neuron works. We also put these artificial neurons in layers, and we make each neuron. So there are, in this case, we have got 3 layers of neurons. Each layer contains 3 neurons. Consider them as neurons, and we make each neuron to talk to other neuron, talking in the sense that one neuron's output is actually fed to another neuron's input. Like a input is coming to this neuron and it flows this activity, and then that particular output, if it generates, goes to the next neuron. The same output is going to this neuron. And similarly, this neuron accepts three input, one from here, another from here, and another comes from here. So they get summed up, and then there exists a threshold function which decides whether output will be generated. If output is generated, then that output is fed to this neuron. Similar way, this neuron is accepting output from this neuron or this neuron, and then an output is getting generated from here. So this is the way actually neuron is making up the entire artificial neural network. The same way a neuron is actually, multiple neuron makes up a biological brain. So what are the key points I discussed? I discussed that biological brain with lots less speed, with lots less resources compared to today's computer system can do extraordinary things. Our computer system cannot match with them. So what was the reason? I explained that reason is parallelability and the fuzziness and or you can say ambiguity of their working. So what we have to do? We have to mimic their way of working, and we have done that. We created our own artificial neural, and like biological brain, we stacked them up in layers, and we tried to do the things the way biological brain works. That is, it only generates output for some specialized input, does not generate output for every kind of inputs. I hope you learned about neurons in artificial neural network. To learn more about it, to know more about it, please come join Globsyn Physics.